We've come to an IVF clinic to see our inner reptile. And Sepna and Dev have graciously allowed us to see their 8-week-old fetus and what's going on inside.
Let's shrink the image a little bit. Oh, well, look at here. There's two. We have twins.
Did I tell you our life's about to change?
In the first few weeks of pregnancy, it's almost as if the embryo is a window back in time that reveals our evolutionary history.
This is the head, this is the heart, and this is the tail. And here's the yolk sac.
Oh, let's see. Oh, wow, there you go. You know, you don't think about yolk in a human, right? You think of yolk for chicken eggs.
Chicken eggs.
Is that extra large or jumbo?
It's organic, free range.
Free range, exactly.
When you think of yolk, you don't think of humans. But we have a little yolk sac in early development that gets smaller and smaller as the embryo develops. There's no yolk inside. It's a remnant from a time when our ancestors laid eggs. And that's not the only gift they left us.
This little bright white line around there is the amnion. And then the black around the baby is the amniotic fluid.
The amnion forms a fluid-filled sac that cushions the embryo. When a mother's waters break, this is the sac that bursts.
That little tissue represents something that happened hundreds of millions of years ago and our connection to one of the great events in the history of life. $375 million years ago, life took a critical turn. For most of evolutionary history, our ancestors needed to live in water. It's where they fed, mated, and most importantly, laid their eggs. But when the first vertebrates ventured out onto land, into a completely alien world, they faced a life and death challenge. How to prevent their eggs from drying out. Amphibians got around the problem by returning to water to lay their eggs. Reptiles evolved a far more radical solution, a whole new type of egg. They enclosed their embryos in a sac filled with fluid, the amnion, and then covered it with a protective shell. This meant they could lay their eggs on shore and start to invade the land. This innovation opened the floodgates for totally new kinds of animals. From snakes and birds to crocodiles and turtles, and eventually mammals like us. That egg-laying history shows up in more than just our anatomy. It's also written in our genes.
What's really amazing about genes is you can look at their changes. That is, you can compare the genome of a human to the genome of a reptile, to the genome of a chicken, and you can ask the question, how are they similar and how are they different? And that's exactly what researchers did.
They searched for a particular kind of gene that produces yolk in the egg. Reptiles and birds have several of these yolk genes that produce gobs of yolk protein to feed the embryo.
Guess what? When researchers looked at humans, what did they find? They found we too have yolk genes, but they're no longer functional. They're knocked out. They're derelicts.
That's because long ago, our ancestors stopped relying on yolk to nourish their embryos. The yolk genes began to decay, until eventually they produced no yolk at all. But those broken genes still lie buried in our genome, like fossils from the past.
So what the genes tell us, what DNA tells us, is that we have come from an egg-laying animal. We're related to egg layers. We're related to reptiles. We carry the genetic signature of our eggy past inside of us.